Now, which point is not in the solution set of the following? Well, of course the answer is going to be choice A as indicated, but is B actually a solution? Well, when we put in 7 for the y value and -1 for the x value, we would have 3 times y, or 7, plus 2. Does that really equal, when we use -1 for x, we would have -1 squared minus 5 times -1 plus 17? Well, we would have 21 plus 2, also known as 23. Is that really the same as 1 plus 5 plus 17? Or, like 6 plus 17, 23? Yeah, that is true. So choice B is eliminated. Now, how about choice C? Does that work? Well, if we had 2 for x and 3 for y, that would be like 3 times y plus 2. Is that really equal to, when we use 2 for x, we have 2 squared minus 5 times that 2 plus 17? So we would have like 9 plus 2 is 11. Is that really 4 minus 10 plus 17? Or like -6 plus 17? Yeah, that is 11. So it won't be choice C. Now, I bet D is also going to be a solution, because A is the correct choice, of course. Well, x and y would both be 5 this time. So how about 3 times 5 plus 2? Is that really the same as 5 squared minus 5 times 5 plus 17? I used less parentheses this time, not a huge deal. Well, we would have 15 plus 2 is 17. And we would have 25 minus 25 plus 17. So 0 plus 17, of course, is 17. So it won't be choice D. Now, when we use choice A, the difference is we won't get a match. That won't happen this time. So how about 3 times y is 10, and then we have plus 2. Is that really not the same as when we use x is 2? So we'd have -2 squared minus 5 times -2. And we would have plus 17 still. So we would have 30 plus 2 is 32. Is that really not the same as we would have 4 and then plus 10 plus 17? So this is like 27 and 4 more would be 31. Womp womp. So that's our only non-solution, making choice A the winner. Now for the bottom problem, if we have P is this and M is that, then what would the solution of, P equaling M be? So what would happen if we took our 2 ln of x minus 1 and we set that equal to M, which is ln of x plus 6. So my recommendation here would be to use the multiple choices. Would 1.65 work? So we would go to our graphing calculator. Maybe we'll try it this way. So would 1.65 on the bottom actually work? So we would have 6.25 inside of ln. That would be multiplied by 2. And we would subtract 1. So choice A would give us like a 2.67. So 2.67. For choice A. Would that match the opposite side? So let's clear all this out. Let's take our 1.65 and we're going to need to add 6 to it. So plus 6. And whatever that answer is, we will take ln of it. So there's this nice ln button. And we get 2.03. So that is not a match. So 2.03 is not a match. So it's not choice A. So how about choice B? How does that stack up? So if we use 3.14 from choice B, let's see what would happen. So we have 3.14, and we're taking ln of it, so the ln button. Then it's multiplied by 2, and then we subtract 1. So that's a 1.29. 1.29. Now let's compare that to when we use 3.14 as x over here. So we would have our 3.14. We would add 6 to it. Then we're taking ln of the result. So we take ln of 12.28, and we get 2.51. So that is not a match, making choice B not true. Now, what if we use choice C? So choice C is indicated to be the correct answer, but what happens when we use 5.62? So let's find out. We would need 5.62, take ln of it, multiply it by 2, and subtract 1. So that's 2.45, roughly. And what happens if we use the other one? So we would have our 5.62, we would add 6 to it, and whatever that answer is, we would then take ln, and we get this same 2.45-ish. So that is a match, making choice C a nice winner here. So choice C is the correct answer. However, if we look at choice D, no solution, that's not exactly true because we just found one. So in conclusion, we know that choice C is the correct answer for this problem.